Okay, so you don't forget on Wednesday. Okay, so let's look at 39 on page 405. So that is y equals tangent twice x plus pi over 2. If we did this problem, I can choose another. I don't remember. Did we do 39?
Yeah, we did.
Okay, then forget about 39. Thank you. Okay, did we do 49?
We did 44. And no, we didn't do 49.
Very good. So let's start with 49. Thank you. Tangent 2/3 x minus pi over 6. Does tangent have amplitude?
No.
No.
No sine, cosine.
Only sine and cosine. Very good. What do I have to do first? So, of course, the first question, every time I'm asked to graph, so that's the question here. Graph this function. First, I have to find the period. And yes, so for the period for tangent, it will always be pi divided by the number that multiplies x. So that is normally called or denoted by k. So what is the number that multiplies x in this problem? Now here, you can say 1. No, you can't say 1. You have to say, okay, 2x plus pi, right? So here I would say that the number that multiplies x is 2. But here I would say that the number that multiplies x is 2/3. So I have to divide by 2/3. When I divide by a fraction, I have to flip the fraction. So then the period for this will be 3 pi divided by 2. Number 2, I have to pull that 2/3 out, but not out of tangent. So you cannot ever write the 2/3 in front of tangent. All you can do is factor it out in front of parentheses, still inside tangent. So don't make that mistake. I'm not saying you will, but I had to mention it. Okay, so then y equals tangent 2/3, and now in parentheses. Why do I do this? Because only when I pull out the 2/3, I will be able to identify what? What am I after now?
Face.
The phase shift, exactly. So then 2/3 times what will be 2/3 x? That's why I pulled out the 2/3. So what is left? X minus.
5/4.
So I have pi over 6, correct, divided by 2 over 3. Pi over 6 divided by 2/3. I have to flip the denominator. And I will simplify, and it is indeed pi over 4. You can always take a moment and verify. 2/3 times x is 2/3 x. 2 over 3 times negative pi over 4, is that pi over 6? Correct. So now I'm able to identify the phase shift. So the phase shift is pi over 4, and it's to the right. Get right. And now I need to establish an interval for this. Right, how did we do it before? Because it's not going to be exactly the same now. How did we do it for sine and cosine? We said b, comma, b plus the period to show the entire period, correct? So b, comma, b plus the period. Well, here I have that problem with those asymptotes. So for tangent and secant, so I'll have the following. B minus pi over 2 I should don't write it just yet. I just want to write it. Don't write it. I don't want you to have to erase anything. I just want to check something. So b minus pi over 2 and b plus the period and plus pi over 2. I want to check something before I conclude. Okay. So in y equals, I have the function tangent. Make sure that, since I'm using pi, make sure that the mode is in radian. It is. So in y equals tangent 2 divided by 3. You have to be very careful how you put that in. You either write 2x over 3 or you put parentheses around 2/3. Be very careful, because otherwise you're going to get something else. So I prefer writing 2x divided by 3. So I don't have to use parentheses inside. And then minus pi divided by 6. And close the parenthesis. Now the viewing window. So I have b, which is pi over 4, minus pi over 2, and x maximum, b plus pi over 2. So b is pi over 4. Pi over 4 plus pi over 2 is 3 pi over 4. And plus the period, which is 3 pi over 2. And then the scale, I'm going to say pi over 4. Oops, I didn't mean that. I meant this. I just want to see one period, and I'm trying to see if I can just present one period. It doesn't matter. You can present as many periods as you want. Okay, so I'm going to say negative 6 to 6. That's good enough. And graph. I don't want those little pieces here and there. That's why I'm trying to... Okay, so I see... I'm going to adjust it right now. So, of course, it does not cross the x-axis at the origin because it's a right shift of pi over 4. We knew that. So, I have 1, 2, 3. So it's pi over 4 plus 3 pi over 4. 1, 2, 3. Pi over 4 plus 3 pi over 4. And on the other side, I have b
So it's a pi.
minus, so this is pi over 4 right here,
Yeah.
plus the period, and b minus the period. I just don't want to see all this. I just want to see just one stretch. So 1, 2, 3. So the right...
So yeah, does the x.
Yeah, so the x maximum should be b plus the period. That's good enough. That would be pi over 4 plus pi over 4 plus 3 pi over 4.
So that just pi.
Good enough. And with a scale of pi over 4, that's good. But now the negative side, I want exactly b minus pi over 2. So I do want negative pi over 4. I want to go how far to the left? I want 3 pi over 4 to the left. Yes. So it's negative 3 pi. I don't know why I'm doing that. 3 pi over 4.
Oh, you missed it.
Yep, I missed it again. Insert a 3. Okay. because I put the positive, that's why. Negative. So negative, I have, it's shifted pi over 4 to your right. So I have negative 3 pi over 4, correct. Negative 3 pi divided by 4. Okay. It still shows a little bit here and a little bit there, and I didn't want this piece. So it's 1, 2, 3. It's 1, 2, 3. This is okay. So B, which is pi over 4, and I go 1, 2, 3. Okay. There is no need for you to do something like this. So it's negative pi over my negative. I don't know. Negative pi divided by 2. Yeah. Okay. Finally. Just because I didn't want to see more than one period, but there is no need. So the entire graph is shifted pi over 4 to the right. So this is pi over 4 plus pi over 4, which is pi over 2. And it goes from pi over 4, 1, 2, 3, pi over 4. So going back to establishing the, so the left-hand side was negative pi over 2, and the right-hand side was, there was 1, 2, 3, 4, right? 4 pi over 4, so it was pi. Okay, so B was pi over 4, and B minus pi will give us, yeah, there is, I'm trying to figure out how to give you a recipe for this. That's what I'm trying to figure out. So, because it doesn't work in the same way it does with sine and cosine. That's the problem. So a sine of cosine is B, and B plus the period, and you're done. No matter what. This will always be for sine and cosine. And also for cotangent and for cosecant. Tangent and secant have this issue. If you want to see just one period, you don't have to. You don't have to see just on the viewing window just one period. You don't have to. You can copy more than one on the graph. But so all these work with this. But tangent and secant don't. If you just want to see. That's just an exercise that is not necessary at all. So how do I get a negative pi over 2 when this is pi over 4? So negative pi over 2 equals pi over 4 plus x. So negative, yes, so x equals negative 3 pi over 2. So this will be the period, negative the period. But actually it's b minus the period. Okay. B minus the period, so that will be pi over 4 minus 3 pi over 2. Right? So pi over 4 minus 3 pi over 2. No, negative b plus the period. So negative b plus the period. Negative plus. Again, I need a little bit of time to figure this one out and give you a recipe. But there is no need. The book doesn't ask you to do something like this. I just wanted to stick with those, but there is no need. So So this is the interval. We can figure it out, and I will think about maybe I can come up with a recipe. They didn't come up with a recipe. I haven't spent enough time on it to come up with a recipe for tangent. So if we want to graph it, the asymptotes obviously are x equals negative pi over 2, 1, 2, 3, 1, 2, 3. Here's the graph. Of tangent 2/3 x minus pi over 6. And then here x equals 1, 2, 3, 4. So it's x equals pi. So the vertical asymptotes, negative pi over 2 to pi. And of course, pi plus pi over 2 is indeed the period, as we expected. Period equals 3 pi over 2. I don't have yet a recipe for finding the correct interval for all of them. Let's look at cotangent. So cotangent x. So f of x equals cotangent x. And we know cotangent is a function that is cosine x divided by sine x. Like tangent, it has different situations. What are the situations? What are the possible problems here with cotangent? When sine is?
0.
Right. So when sine is 0, there is a problem. The function will have vertical asymptotes. Good. So now let's look at the unit circle and try to graph cotangent like we did with all the other ones. Pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi, negative 3 pi over 2, pi over 2, pi, 3 pi over 2, 2 pi. Very good. So, first of all, where is sine 0? Remember, sine is measured on the y-axis. So where is sine 0? Because I will have to draw the vertical asymptote there. Sine is 0 at, yes, at 0. Very good. At pi. And 2 pi, very good. And on the negative side, very good. And so on and so forth. Awesome. Good. So like before, I'm going to ask you, where is cotangent 0? Cotangent is 0 when which of these is what? Very good. Where is cosine 0? Awesome. Good. And continues forever on this side and on that side. Perfect. Now I would like you to tell me which quadrant is this.
The first.
Yes. What will be the sign of cotangent in the first quadrant? What quadrant is this?
Second.
Which will be the sign of cotangent in the second quadrant?
Yeah.
Very good. That's how we remember it. It's pretty similar to tangent, but it's a reflection if you want. And You know what this, how it will look like by identifying each quadrant. So this is the graph of y equals cotangent x. Is this function 1 to 1?
Nope.
No. But what if we do this? Be very careful now. That's when things get complicated. Is this function now? Is this 1 to 1?
Yeah.
What type of function did we say cotangent was? Odd or even? We're talking about cotangent.
Tangent's odd.
Tangent is odd and cotangent is odd. As long as, if they have sign in them, they have to be odd. Only two functions are even. The ones that do not have sign in them. Cosine and secant. So that's the reason why we will be defining this in a kind of a interesting way. Between negative pi over 2 and pi over 2, including negative pi over 2 and pi over 2, but not including what?
0.
Yes. Yes. But not including 0.
Why wouldn't you use 0 to pi? Or is it because you want the symmetry?
I want the symmetry, yeah. Yep. 3. Secant. By definition, secant is 1 over cosine. So therefore, it has a problem. What is the problem? Cosine x cannot equal 0. Very good. So let's look at the graph. Negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, where is cosine 0? Very good. Okay, now let's think for a moment. Ready? Okay. What quadrant is this? 1. What is the sign of cosine in the first quadrant?
Positive.
Correct. What is the maximum possible value of cosine being positive? What are the values? Maybe I should ask this. What are the values of cosine between 0 and pi over 2 for x between 0 and pi over 2? What is the maximum possible value? 1. What is the minimum possible value?
In that quadrant. 0.
Yes, but I cannot divide by 0.
Right.
So 0.001. When I divide 1 by 0.001, what type of number do I get?
Almost 0.
Careful.
Oh, wait, no, it's 8.
On the other side,
Yeah.
huge,
Yeah, big number.
huge number. Okay, so here is what happens. And this is the minimum possible, because when cosine is 1, 1 over 1 will be 1, and when cosine is smaller than 1, it will blow up. And this is the fourth quadrant. Therefore, cosine is positive here and here, so that's why it looks like a parabola. It's not, because it has vertical asymptotes. It cannot be a parabola. Okay, what happens here in the second and third? Identical, but where?
Facing down.
Exactly, on the negative side, and this is -1. Of course, the graph is not there. Careful. I'm just putting a -1. So here will be the graph. So this will be -1 here. Okay, what happens next to the right? Obviously, will be a copy of what I have in the first and the fourth. So the minimum value will be 1, but the maximum will go all the way, and so on and so forth. Different books will, even for cotangent, different books may say, okay, this is the domain. Other books will say this is the domain. Here, some books will consider this as being the domain. So as you see, there is just a little blurb about the inverse functions for secant, cosecant, and cotangent in chapter 5, and about these functions, graphs of these, you find them on page 403 and 404. Of course, this is not secant, this is secant. I don't know how they come up with. Oh, it's because it's a transformation. I'm sorry, I jumped into a transformation directly. They don't even present the graphs. They go directly to some transformations. Actually, they do on page 401 a little bit. Yeah, they do a little bit. So they do show the graph of secant. And this will be the last one, the graph of cosecant. They do show the tangent. They do show the cotangent. But that's pretty much it. They're all useful functions. However, sine, cosine, and tangent are the most used, common ones. Okay, let's look at the last one. So y equals cosecant x, which is 1 divided by sine x. And we know that sine x cannot be 0. Where is sine 0? So I can put a vertical asymptotes.
0 pi, 2 pi.
Sine is 0 at 0. Indeed at pi, 2 pi. So x equals 0, x equals pi, x equals 2 pi, x equals -pi, and x equals -2 pi. Okay, so what quadrant is this? Yes, what quadrant is this? So sine has what sign in the first quadrant and the second quadrant? And it will be exactly the same argument. If sine is the maximum, which is 1 in these two quadrants, 1 over 1 will be 1. If sine is a tiny number, 1 over a tiny number will be positive infinity. So that's why the minimum here is at 1. And here the maximum will be at -1. So this is at 1, and this is at -1. And it will go on forever, alternating, of course. I'm not going to ask you to graph these three functions. I'm not going to ask you to find anything else but maybe just their period or phase shift. We are not going to talk about the inverse functions for these three, for cotangent, secant, and cosecant. There's not enough in the book to warrant that. And in calculus, we will discuss these functions, but briefly and only when we talk about differentiation and differentiation rules and other things, but not graphing them. Yes, Paul? Yes. This one?
Yes.
Of course, it's this. The cosecant is a shifted graph of pi over 2 to the right. Okay, this completes what we need to look at for this test. And I put a previous test on your table and or desks, and I like to go over this as quickly as we can. Ready? In preparation for our test. And I recommend the test to be a week from today, if that's okay.
So, in class?
No, if you want to take it in the testing center next week, that's fine.
Okay.
The-
So we have all next week?
All next week, yeah.
Okay.
I'm fine with that. Is that okay with everyone?
Yes.
Okay,
So take it by Friday or
By
Saturday?
Friday. So I can grade it on Saturday, take it with me, otherwise, yeah. Okay, very good. So let's start by doing this. Ready?
Did you have it in by this Saturday?
I'm sorry?
Just in case.
Yes.
Okay.
Yeah, just let me know. You want me to give it to them on Saturday or Friday?
Yeah, I might take it this Saturday.
Okay.
Taking out the weekend's easier.
Okay, very good. I'll write it. Okay, so we're working on number 1. And Paul, starting from Wednesday, we're going to start 15 minutes early. We have to make up for the last Wednesday. Can you make it?
Yes, I see it changed my schedule. Okay.
13 minutes. I need to start for the next 10 sessions. So I can give, it's mandatory for us.
Okay.
Otherwise, we get in trouble with the local government because we get funding from them. Okay, so we are working on problem 1, correct?
Yes.
Do we have an answer already? Or okay. Do we have an answer for 1A? Is that a yes? Is that a no?
That's only 2,500.
So here's what I would do first, right? Negative 0.01 x squared plus 10x. First of all, mandatory. The quadratic function has to be presented in descending order. And then it says, what is the maximum height of the that the cannonball reaches, right? So I have to find the vertex. Negative b over 2 times a. So that is multiplied by 100, so it's 1,000 divided by 2, so this is 500 feet. But in order to find the maximum height, Yes, I have to find h of 500. And that is negative 0.01 times 500 squared plus 10 times 500. And what did we get? 2,500. Measurement unit? Good. Now, how far does the cannonball travel horizontally before splashing into the water? What we are asked here. Is everyone okay with part A? Okay. So part B, what am I asked to find in part B? Yes. In other words, the X intercept.
Yes.
Perfect. So let's find the X intercept. So that was part A and part B. How do I find that? Say it again.
Use a quadratic.
Right. However, this is a much easier situation because the free term is missing. So negative 0.01 x squared plus 10x equals 0. I will divide both sides by negative 0.01 because I don't like it in there. This is just me. You don't have to. Okay? So this is x squared and minus 10 divided by 0.01 will be 1,000 divided by 1, correct? Because I need two zeros. So 1,000x equals 0. And then I will factor. And this is easier for me. You use what you want. X equals 0. Of course, this is not the case because I'm not talking about the launch where I'm standing and throwing it up in the air. I'm talking about where. Yeah. So I have to find two X intercepts, correct? So and the other one x equals 1,000. So it does. In other words, it says this. It says this is 1,000 feet. This is 0 feet. And here I have 500, and the height is 2,500. So that's all it means. Are we comfortable with this?
Mhm.
Yes?
Yeah.
Okay. Problem number 2. Let's work on number 2. Use the method of your choice to divide this by this and state if p of x is divisible by x minus 2. I was looking to see if they do give a recipe for something like this for finding the interval, and they don't. They don't have a recipe for it. They just say, okay, this is the graph of this shifted to the right pi over 4. So when we're asked to divide, then we have to find the quotient and the remainder. So you can either use the synthetic division or use, in this case, or use the long division. It's up to you. It's not specified. And what if I ask, find, if it is divisible, find the other factors? If you can. Let's finish this one and let's discuss the other possible questions.